Hey AAF students, welcome back. So in this lesson, we're talking about matrices, which I think some of you guys might not be new to, but I'm really excited about this unit because it's new, right? Like not many of y'all have learned really much about matrices in general. So we'll learn them. We'll not do too much this year. You'll do more with it next year. This actually, some of you guys, I think there might be one or two middle schools that do matrices in geometry because you can do transformations, if you remember that, with matrices. We're not going to go quite that far this year. You'll get that more next year. So I thought this was a fun little thing to start with. So we're learning about matrices. We're going to do the real ones. So you guys have access to this PowerPoint, and there's also a supplemental worksheet posted, and I'm going to be doing some of the problems from that worksheet actually. So if you wanted to have it, or if you print it out, or you want to take a look at it, that would be a great resource as well. And when we see you next week, there's nothing that you're submitting for this introduction this weekend. So when we see you next week in class, we're going to be kind of extending on this. You'll have an opportunity to ask questions. So maybe write those down as you're watching. So our objective is to, it's very much introductory. So we're going to define a matrix. So we're going to know how we talk about these. We're going to know how to identify parts. And we're going to begin to perform some basic matrix operations. And so those operations that we're going to do in this, like basic operations, are addition, subtraction, and what we refer to as scalar multiplication. Matrix multiplication is actually not a basic operation. So we're going to be dedicating a little bit more time, both through video lessons and in class, to talk about that multiplication. And there really isn't, there is division, but it's more like, think about when you divide by a fraction. It's more going to be like multiplying by the reciprocal type of thing, or multiply by the inverse type of thing. And so we'll talk about that later. So in this, I know I just went off on a tangent, but in this video, we're going to be talking about adding, subtracting, and what we refer to as scalar multiplication. Right? If you scale something, if you're multiplying something by a scalar, it's by a number. You're not going to be multiplying two matrices together. That will come later. So first of all, what is a matrix? A matrix is a rectangular array of numbers often used to organize data. The dimensions or order of a matrix are determined by counting the number of rows and the number of columns. So the number of rows and the number of columns. So this matrix that I have right here, oh no, I don't want an arrow, is a 2 by 3 matrix, right? So it's the rows by columns. That's an important one to remember, right? So if you're asked to identify which of the following are 2 by 3 matrices, knowing that it's rows by columns. 2 rows, 3 columns. So let's see. Hugh worked 3 hours on Monday, 4 hours on Tuesday, 7 hours on Wednesday, 6 hours on Thursday, and 5 hours on Friday. Abby worked 2 hours on Monday, 4 on Tuesday, 3 on Wednesday, 2 on Thursday, and 5 hours on Friday. And then Maya worked 2 hours on Monday, 5 hours on Tuesday, 3 hours on Wednesday, 7 hours on Thursday, and 7 hours on Friday. Record the information above in a matrix, and we're going to refer to it. This is like the name of it. Matrix A. Right, so maybe take a minute and see if you can do this. I guess if you have my PowerPoint printed, you already see it. So let's see, did you get something like this? Right, so the way I set it up, it's 3 by 5, right? This is a 3 by 5 matrix, 3 rows, 5 columns. So I did this, right? This is Hugh, this is Abby, this is Maya, and this would be Monday, Tuesday, Wednesday, Thursday, Friday, right? That's like, I essentially took a word problem and made it into a matrix. Okay. Realistically, I didn't get super specific here. I could have set it up so that it was Monday, Tuesday, Wednesday, Thursday, Friday, and then Hugh, Abby, Maya going this way, right? And I could have had 3, 4, 7, oh no, 6, 5, right? These actually have a relationship that we're going to talk about, right? Like I can switch the rows and columns and make my 3 by 5 into a 5 by 3 by switching the data. And this is actually called the transpose. So I'm getting a little bit ahead of myself, but I thought it was important to say here, right? So A transpose. So if I refer to this as A, this is actually A with a little t superscript, right? And this is A transposed. What are the dimensions? I'm getting way ahead of myself. Of course. What are the dimensions of this matrix? We set it up and it's 3 by 5. What is the value of A24? So this is where it's really important to remember that it's rows by columns. The value of A24. So it's the second row, fourth column. Right here. 2. Write down the transpose. See, I just said that. So if I wrote it down, my first row becomes my first column. My second row becomes my second column. My third row becomes my third column. Right, so you can see now my first row was actually just my first column. That's A transpose. That's what this means. That's what that notation means. Transpose. It's a new vocab word. What is the new location of that entry? I'm sorry, of the entry that was previously A14. Well, without even looking, it's got to be 4-1, isn't it? Let's see. 1-4, first row, right here. Oh, that ended up right here. 4-1, right? You're switching them. It's not the inverse, it's the transpose. Are matrix A and matrix A transpose the same matrix? No. It displays the same data. Well, I mean, they're different matrices, right? Like it would depend on what I was doing with this. Like sometimes it's going to be necessary when we're dealing with applications. It may come up, right? If you need to, and we haven't done this yet, but if you need to add this to something else and we're looking for common values, right? Like you can't, like, it's like combining like terms. I might have to transpose it to be able to compare it with something else. Let's say we were dealing with solving a systems of equations. It would be important to know how to do this, right? I'm just thinking ahead a little bit. So no, they're really not the same matrix. They represent the same data, but they're not the same exact matrix, right? One of them is 3 by 5. The other one is 5 by 3. But it does display the same data, just in a different representation. What is the dimension of a transpose of a matrix if the original matrix is 5 by 2? 2 by 5, right? They switch, rows and columns switch. So we're gonna look at some basic operations. Now that we know about the dimensions, how do you find a certain cell, right? Like A14, finding a specific cell, and transposing. We're gonna talk about adding, subtracting, and scalar multiplication. So this is on a worksheet that is listed under supplemental resources, and I'm gonna skip around a little bit. And then I encourage you to maybe work through some more of it, if you so please. So when I add these two, I'm literally just gonna add their cells. Okay, so 3 and 0, I get 3. 6 and -1, I get 5. -1 and 6, I get 5. -3 plus 0, I get -3. -5 plus 2, I get -3. -1 plus 3, I get 2. That's my answer. Hoping that's reasonable. Here I'm subtracting. Some of you all might like to change this to addition and make all of these opposite, right? Maybe that's how you work better. You have to think like you're basically distributing, right? I'm doing, let's say this was A, it's A minus B, right? So you're subtracting. -5 minus 6, -11. You just gotta be careful. 2 minus -5, that's like 2 plus 5, 7. Negative 2 minus negative 6. That's like negative 2 plus 6. 4. 4 minus 1. 3. Negative 2 minus 3. Negative 5. 0 minus negative 3. Positive 3. And that's my answer. This right here, this is scalar multiplication. I'm basically going to be distributing this to all of the cells in here of this 2 by 3 matrix. So my new matrix is going to be negative 25, negative 30, 20, negative 20, 10, 5. Done. What's this? This is a 1 by 3 matrix. 1 row, 3 columns. It looks a little funny. And a 1 by 3. So I'm going to be subtracting negative x minus 1 minus y. Negative x minus y minus 1. That's what the order I'm going to choose to write it in. Negative 2x minus negative 2. Negative 2x plus 2. Negative 5y minus negative 3x. So 3x minus 5y. Right? So you've got to be pretty neat about this stuff. You want to be as neat as you can be. Organized. Some people like this because it helps you stay organized. You got to be able to read your handwriting. Let's see. Here. So it's like I'm doing 5a minus b. Order of operations, I've got to multiply first before I can subtract. So scalar multiplication, 35, 10, negative 30, minus 1, 6, negative 6, 6. And then subtract. 30 minus 1, 5 minus 6, 10 minus negative 6, 16, negative 30 minus 6, negative 36. Here, I can either distribute that negative 5 or I can add and then distribute. I'm going to add first. But I've got this negative 5, since there's parentheses here, would go to everything if I wanted to do it that way. So I think I'm going to add first. 2, negative 2, 7, and then go, box. And go ahead and distribute. Negative 10, 10, negative 35. Let's see. Oh, I don't know why. Yeah, I'm going to rewrite this. 6, negative 4, 0, 0, plus, I'm going to distribute that. Negative 20, 5, negative 20, 30, 5, negative 5, and then I'm going to go ahead and add. 1 plus 20 is negative 19. 1 plus 30 is 31. 6 and 5 is 11. Negative 4 and 5 is 1. 0 and I can't read my own handwriting. Negative 20 is negative 20. 0 plus negative 5 is negative 5. So one of the things that I haven't spoken about yet that's really, really important is when we are adding and subtracting, the matrices must be the same dimensions. If I wanted to add two matrices or subtract them, and I add, let's say, 2, 4, 7, 9, and then I add plus 1, 3, 2, 8, negative 4, 6, I can't add these. Cannot be added. They are not the same dimensions, right? Like I get stuck here. This is not possible, right? These can't be added together. So it's good to recognize before you go in and try to do something. I'm not going to like add part of it. Like I have to have them be the same dimensions in order to add them. Okay. So like there would be no solution for this one. So to close off, because this is just the operations, we're going to come to, when we come together, we'll review the operations and we'll look a little bit about how we can use this to solve equations, which is basically what you already know about solving equations. I just happen to have a matrix involved. Can you do this one? Our goal here, what is our goal? Solve for x. I don't have directions. Solve for x. Here's x. Found it. So I'm subtracting. I've got scalar multiplication. So I'm really just going to focus in on this stuff. I can basically set up an equation. 25 minus 3x has to be 15. Notice all of these are 3. I'm sorry, are 2 by 2. Right, so that's enough. I'm not like leaving that cell, right? That cell is, it's the first row, second row, first column, right? I'm looking at the second row, first column for all of them. So I can solve this now, right? I can subtract 25, negative 3x equals 15 minus 25, negative 15. No, negative 10. Right, yeah. And then divide by negative 3, and we're not afraid of this, 10/3. Right? If you plug that back in, that makes sense. 25 minus 3 times 10/3, so minus 10 is going to give me 15. Did you think of a different way you could have done this? I can actually subtract this entire matrix from this side and do it that way too. Right? I can do it, I can say, you know what, instead of, I mean, I could also simplify this and leave it with the x and then take those two cells. It's just nice to be able to recognize right here that I just need to focus in and like hone in on that part. So we'll be doing stuff kind of like this where we've got equations and matrices when we see you in class. Right? So through this lesson, and I didn't want this to be too long, I just wanted you to kind of define and see like what questions you might have so that we could do some practice and work together with some more involved problems when we see you to really apply this. So we defined what a matrix is, right? It's that rectangular array. It can be used for transformations. Some of you guys may have seen it in geometry. Not all of you. I'm kind of operating with the assumption that you've never learned this before. Identify parts of a matrix, so knowing how to figure out that it's rows by columns, knowing what a transpose is. We introduce that vocabulary. Identifying if I say like cell 1, 3, knowing where do you look for that, and begin to perform some basic matrix operations, which we defined as addition, subtraction, and scalar multiplication. So hopefully you got some practice with this. I encourage you to use some of the supplemental resources. If you don't have any assignments related to this due for us, you just have the practice like the IA, the group project, that you should continue to work on over the next week or so. So if you've got questions, we will be happy to address those when we see you next. Thanks, everyone.